Right? So normal characteristics of an operational amplifier. This is an example of one here. All right, simple op amp. You have inputs, the op amp itself, and the output. All right, so two things you have to remember. These points here. Oh, it does always happen. Yeah, literally like, all right, yeah, these 2 points here, they are normally called virtual Earths because the potential of them are normally equal. Well, not normally, they are equal. And one thing I have to remember is no current is going inside of this. Yeah, it have no current in going in. It just is a sensor. It doesn't really have any current flowing into the op amp itself. If there are currents flowing, it's extremely negligible or extremely small. So in ideal situations, we assume that the currents into the inputs are zero. Yeah. And also one thing I have to remember is that the op amp will always try to make V plus and V minus the same. So when you subtract them, you'll always get zero. Yeah. So if you put this number one here, if you want to know why is infinity, because AV is equal to V out and Vn. Vn here is the difference in between two of these, right? So in an ideal situation, these two are the same. So let's say it's 2 and 2, right? 2 subtract 2 will be 0. So therefore, this Vn here will be 0. Yeah? So therefore, this here divided by 0 will be infinity. But in ideal situation, V plus and V minus aren't the same. So you'll have a normal voltage gain. Right? But in ideal situations, V plus and V minus are the same. If you subtract two of them, you'll get 0. Any number divided by 0 is infinity. So that is what these two come from. Note you really not ask you all that. Yeah, but these are nice too. If socks, it's a right three ideal characteristics of op amp. These are the two. Simple. No current in the inputs and infinite voltage gain. Or open loop. They normally say open loop gain. Right, so let's run through this quickly. Right, so as we go in through, the thing we have to pay attention to is how the circuit looks and the equation for V out and V in, because that is what the past paper will ask you. So if you go across to the past paper, this is the section you'll need the lecture for. It will say sketch the following operation amplifiers and say the output in terms of input, basically the equation. Yeah, so I don't know how to sketch non-inverting, inverting, all these things, you need to know how to sketch them. I need to know the equation for each of them. Once you know that, it's 3 marks. And the questions normally say the same. So there's 2012, 2015 is less, but it's the same thing. Yeah, it's literally the same thing. 2013 is the same thing. It didn't change. So I'll say once you do it once, you get through. Yeah, once you do the past papers, like questions like these 4 characteristics, yes, I gave you 2, right? So other ones, it has infinite outputs, sorry, 0 output impedance on the output side, infinite input impedance, infinite open loop on, what's the other one? No currents is taken into the inputs. Those 4, I just memorize you 4. Yeah, so just memorize it. Right, so let's go through this. So the so the first type, I think you all probably should know about it, is the unity gain buffer. Right, it doesn't have a RF, a feedback resistor, it's just wire. Right, so it just takes in an input and gives you back the same input. Literally. So if the VI is 2, it will give you back 2. If it's 3, it will give you back 3. It'll just buffer. Yeah, so I don't know if you still watch YouTube or you still watch YouTube. They normally say buffering. Yeah. This is basically what happened. They're just buffering. VI is equal to VO. Anytime this is not true, you'll kind of get the loading sign on your screen. Yeah, so it's just a buffer. Whatever coming in will go out. Yeah, so the equation you need to remember is this. AF is equal to VO on VI, which is equal to 1. Yeah, so this is where you have to remember. Because this is the equation that you use to say the output with respect to the input, which is what the paper wanted to know. Yeah, So remember. And the voltage gain or the current gain of it is 1, which makes sense. Okay, just matching wherever you're sunny. Yeah? So remember this. That's what you have to remember. Right? I circle it in these slides so you when you get it, you'll know what paying attention to. Alright, the second one is the inverting amp. You don't need to know the proof. You really ask you the proof. Right? What you want to know is this equation. Right? And then if you transpose that to V out, it'll be minus R2 and R1. Normally R2 you just say RF. It's just a convention by VI. Yeah? So that's why I'm using the second part. But anytime you ask you V out and V in, you could use this one or you could use that one. Just remember, I think this one more familiar with you all for the inverting amplifier. Alright, so we're just going through. This one is literally just to sit down and remember the circuit. How does it? Alright, non-inverting amplifier. This should be familiar from physics. The equation for it is here. So you'll use this one here. V out is equal to 1 plus R2 and R1 VI. So you have to remember those equations. Once you remember the equations, guys, you could get all the marks for this section. And obviously, how to draw the circuit. So what I had done is I used to get like a piece of scrap paper and just draw the same circuit over and over and over and over. Yeah, it might sound redundant, but when you're under pressure, knowing that you had the practice of doing it over and over and over, does give you some confidence. Unlike some people that probably never draw it and just say, yeah, man, I can remember that. And when they go in the exam, you forget it. So that you just sit down and be like, okay, inverting, draw the circuit. Non-inverting, draw the circuit. Differentiator, draw the circuit. Integrator, draw the circuit. Unity gain buffer, draw the circuit. And just keep on doing it over and over and over and over. Until you can literally see the circuit when you close your eye. And once you do that, do the same thing for the equation. And there is a free minimum 20 marks in the paper. I remember so says a percent a mark. So each percent, each mark there you get is a whole percent. So just make sure you maximize your marks. So you could at least get minimum 20% in this section, which is a good bit. Alright? So non-inverting, continuing differential amplifier. Alright, so while wait, you also pay attention to for now I want to do the question is this equation here. Because he loves to bring questions which need you to use this. So that's keep it in mind. Alright. So I shall also write it down for when I go to the past paper. Because this, I kid you not for sure, you're gonna get a question that needed to use this equation. Right? If anybody asks when you're gonna need to use the equation, I'm gonna go to the past paper to show you. So, right, so this question here, you notice that the voltage source, you have a battery here. So this here is seeing 2 volts. Yeah, and if you notice, this is a differential amplifier. So if you go back to the sketch flip, look at it here. See it? R1, R2, R2, R1. You have this going here, and you have 2 inputs, V1 and V2. So in this case, V2 grounded, and it have a voltage source. So they kind of like put a battery there. It's used to compare. Yeah, just use as a reference voltage. Should I just remove this piece here? This piece here to V plus, and then just put a battery. So it's still 2. So V plus will be 2 volts. So you're still using this equation. So if you go back to the question, in this case, this is R1, and this is R2. Yeah, so we didn't go to this as yet. But when I show you all it, this is basically 2 op amps. So you have to do it piece by piece. So the V out of this will be the V in of the second one. So it's actually 2 op amps. Yeah. So for the one, let's look at one at a time. Remember I said the battery source connected to one grounded. This is how it does look all of the time. So if I literally go at a different past paper, you will literally see it literally the same thing. So let's see if you can find that same look, we'll come back again. See? Same thing. It's literally the same thing. Same thing, just changing numbers, but the same thing. Look at take a picture of it, take a mental picture of how the question looks. You have a battery connected, and you have this is a differential, and well, this could be anything. The number 2. 2013, Same, well, literally bring the same thing from the last year. Yeah, same question. See the battery? Yeah, take a mental picture. A lot of people that lose marks for that will be like, what is that? But if you tell them it, to answer this, you had to use this equation here, you had to use it. That's what you had to use. So yeah, that's basically transpose to V out, and you get your answer. So let's keep that in mind. All right, keep it in mind. Write it down. And I'll show you how the question does look. Looks like this. Looks like this. Looks like this. Okay? All right, let's continue. So the guy was differential amplifier, and this was the circuit fit. Right? I just circuit fit. Yes. Well, yeah, this is continuing. This is the equation for when associated write the input and output. So that will be the answer for this, for the differentiator. This part here. Yeah, so remember the one to just get the circuit and stay the output in terms of the input. Yeah, so for this one here, the answer will be this here. VO is R2 on R1, V2 minus V1. Yeah, so as I said, you don't need to know all this proof here. So you can just skip it. Just know the circuit and the equation for it. I reiterate to myself for a reason. Alright, and that is the end. That is really all the circuits there. So as I said before, to get total in this section, it's easy. You just have to remember the circuit and the equation for each. In terms of like the V out and the V in. Once you know that, as I say, take out some scrap paper, know, alright, what the types, integrator, differentiator, unity gain buffer, inverting, non-inverting, the summing. Think we have one more. So once you do those stuff and you write it down over and over and you know it by the back of your hand, you could fly through that section. And if you get total in it, so you could get total in it. Alright, I think it has, well, this is the integrator. He will not bring like a question on this because this involves integration. So you all didn't do integration in this stamp course, so you're not gonna bring a question with it. Because if you know this equation for it, right? V out is equal to 1 RC integral of V in. Yeah, he didn't do integration with you. So you're not gonna bring a question. How we will bring this is like this here. He will tell you to sketch it and write the input output equation for it. Yeah? So that's why I need to just need to know this one here. There's the integrator and then differentiator. Like how I remember it is that the integrator is the one where the capacitor is RF and R is the R1 and the differentiator just flip it. You just the capacitor will go here and the resistor will go up. So watch it. Integrator and the capacitor just switch. The capacitor went where R was and R went where the capacitor was. And there's the differentiator. Yeah, and also a differentiator is a high pass. So it basically allows all the high frequency C's to go through. And an integrator is a low pass, meaning that it will allow all the frequencies lower than a certain value to go through. Yeah, so as like somebody screaming, but you only hear the low parts, or if somebody with a real bass in the voice, you will cut off all the low, and you will hear the voice. But if somebody real high, it will come through because a low pass or a high pass, right? That's in the name, circuit, and the equation for it. Yeah, it's not a very heavy theory topic, okay? And differentiator. And the last one is the summing amplifier. This one is the easiest one because it's just inverting, which is minus R1 or R2 and R1, and that's multiplied by the sum of all the voltages. Because normally R1A, R1B, and R1C are the same. If they aren't, you have to do it separately. Yeah, but normally there's the same. So how does looking at paper? Yeah, look at here, summing amplifier. That's the first part. Remember, there's normally cascade the up amps together, right? So you just do it one by one. So this is the first one. This, if you noted, this is our summing amplifier. Yeah. So the equation V out, so V out to be here, would just equal to minus R2 on R1 plus all the voltages. And in this case, R2 is 5, and R1, if you notice, is the same, normally it'll be the same, and again V out. And then when you reach here, you just go and forget about this piece, and now you have a non-inverting amplifier. Then you just slap down the equation for that. Yeah, but that's jumping the gun. Just watch how it does look. So you see if you find it in the next past paper. Super. Right, look at that. The next one. Summon amplifier. 2015. Yeah, summon amplifier. Yeah, that's what you see. It really change. Alright, so and that is the end of the So as I said, once you know the circuit and the equation for it, you get through. Alright, so I jump into the paper. Because we no need to stick. Yeah, as I said, class shouldn't be long today. Once you understand this, you get through. Alright, so I look to start. I'm not gonna do this section because it'll be redundant. Because I drawing over the same thing in these slides. So look through the slides, know the circuit for and non if they say AC, like anytime you see AC, that's put a capacitor where you take any input. And we know how a capacitor does act for DC, and we know how it does act for AC. So if you want an AC amplifier, you could use a capacitor to allow the AC to go through and block the DC. We know how a capacitor does work. Right? So yeah, that's basically putting a capacitor. You're just running and reverting like normal, but where you're putting the input, you just go and put a capacitor. Yeah, that's it. Same thing if they say inverting AC, same thing. You just put a capacitor in it. Right, so you look to do some questions. Right, let's start. So that's how I do the question. So watch carefully. So I just put a dot in the middle, that's to separate it, and I just draw a line. So I will know there's two separate, and I label this one, I label this two. I just do that so I will know, all right, to separate it, I'll do one first, and I need the output of one to be the input of the next one, I just go again. So this here is our inverting amplifier, and this here is our non-inverting amplifier. So they can look at it like that. So let go. So for one, you write the equation. So V out will equal to minus R2 on R1 by Vn. Yeah, so R2 in this case is 10, R1 is 5, Vi is 2. So this will be 5 into that is 2, 2 by 2 is 4. So that means 4 volts coming out here. Now on this side, and I'm gonna go again. So V out final is a non-inverting. Yeah? So we just use the equation, it would just be 1 plus R2 on R1 Vi. And go again. So 1 plus R2 in this case is 3K on 1K by 4. So this will be 3 plus 1 is 4, 4 by 4 is 16. So the output this here will be 16 volts. And that is it. That is literally it. The same steps we use for all the other questions. Alright, so let's try next one. So luckily this didn't cascade this one together. Yeah. So this is a differential amplifier, a differential. Yeah, okay, it have two inputs comparing. So V out, that's equal to R2 on R1 by V2 minus V1. So there's V1 here and there's V2 here, right? Yeah, let's go through. So that equal to R2 is 20 on R1, which is 10K. V2 is minus 1, minus 5. And V1 is 5, right? So that'll be 2 by minus 6, get minus 12. And that is nothing more to do. Once you know what type of op amp it is, you can just slap the equation, plug in the values, and alright, so we have this one here now. So this one here started the cascade it. So you have to be careful. So as I said, there's part dots in the middle and separate it. So I will know it's two separate ones. This is 1 and this is 2. So 1 is a summing amplifier. So we know for summing amplifier, the equation will be minus R2 on R1, all these here are R1, and there's R2 by V1 plus V2 plus V3, right? So that will just end up being minus 5K on 5K by 2 plus 1 minus 4. So this will just be minus 1. 2 plus 1 is 3, 3 minus 4, minus 1, I believe. Yeah, I think so. Yeah, 3 minus 4 is minus 1. So this will end up being 1. So therefore this here is 1. So we are on this number 2 now. And for number 2, this is a non-inverting amplifier. So therefore VO final would just equal to 1 plus R2 R1 by VI. So it'll be 1 plus R2 in this case is 1K, R1 is 1K, and VI is 1. So that'll be 1 plus 1 is 2 by 1, which is 2 volts. Alright, so this output here will be 2 volts. Yeah. And this one here is the thing I was talking to you all about. So you'll notice I have a DC source here. So in order to get V out here, you need to use the equation. So this here, V minus, and well, this is V plus. Alright, so that's how the circuit is labeled. So like if you go back to the slide. So that is this one here. Yeah, so you notice in the equation they use V plus, and so V plus is this here. I'm gonna zoom in. So V plus is this one here, the one at the bottom, and V minus is the one on top. And V1 is the one on top, and V2. So V2 and V plus, V1 and V minus. Right, so and then the equation will just be V1 minus V plus. So wherever node or voltage V plus at, so it'll be V1 minus V plus, and R1 is equal to V plus, which is the reference, minus VO, which is where you want, over R2. So what I do with this equation is transpose for VO, and you get through. Yeah, so we're gonna apply it here. So this is our cascade, so we in one. So let's use the equation. So we label everything already. So there's V minus, there's V1, and well, this we don't really need V2, because the equation don't have that, right? So therefore, they will have V1 on minus V plus on R1 is equal to V plus minus VO on R2. Yeah, so let's plug in the value. So you have 5 and V plus is 2. Yeah, if remember this going from minus here to plus, right? So it could be 2. If the battery was flipped on the other side, like if the minus was on top, V plus will have be minus 2, right? So be careful with the polarity of the battery. Okay, so divided by R1 is 3. Okay, alright, which is equal to V plus, which is 2 minus VO on 3K. R2 is 3K. Yeah, so 5 minus 2 is 3 on 3K, which is equal to 2 minus VO on 3K. So I simplify, so they fling the 3K across. So when they fling 3K across, the 3K will cancel. So you will end up with 3 is equal to 2 minus VO. So therefore, fling the VO on the next side and fling by the 3. So you get 2 minus 3. And then you get VO to be minus 1 volts. Yeah, and I VO'd it. So now we're in number 2 now. So number 2 is a non-inverting amplifier. So let's go again. So VO final will just equal to 1 plus R2 on R1 VI. So this will just be 1 plus 2K on 1K by minus 1. So this will be 1, 2, 3 by minus 1, which is minus 3 volts. So V out here will be minus 3 volts. Yeah? And I think that was probably more. Well, that was the last one. Right? The question was going to be the same. Like the unit cell that would change is in numbers and the numbering for each other. But other than that, he will bring one like this where they use this equation here. He will bring a summing amplifier. He will bring a differential amplifier, which is the one where you have inputs in the two of them. And he will bring a non-inverting and an inverting. Because he will want to test everything except the integrator and the differentiator. Because he never showed you how to differentiate and integrate. So that's not going to come. It will come with like up here, we have to draw the circuit and write the equation for it, but for down here, it's going to be non-inverting, inverting, differential, and summing. Yeah? This what way done with the battery. There's a version of this differential amplifier. Yeah? So that was that question. So just do one more paper because it just being redundant, right? So once you catch it once, you're not gonna forget. There's the same steps you'll be doing, right? Not going to change at all. Alright, so as I said, there's 2015. So I do 2015. I'll do this one. 2K. Yeah, don't matter. Right, so I do this one here and call it. So as I said, the first part of the question is the same. Draw the circuit, write the input and output equation. So it's not gonna change. Alright, so I apply to this one. Alright. If you all have any question, you can stop, alright? So as I said, slap down the steps, part dots, separate it, label 1, 2, so I will know it's 2. This here is an inverting amplifier, and this here is also inverting amplifier. Yeah, so here let's go. So VO would just equal to minus R2 and R1 VI. So that will be minus 8K and 4K by 5 volts. So that will be minus 2 by 5, which is minus 10 volts. So therefore, this here is minus 10 volts. So now we go again. And this here is our next inverted. So it'll be VO final will be minus R2 on R1 by VI, which we just got from the first one. So it will be minus 5K on 5K R2 R1 by VI, which we just get to be minus 10. So that'll be minus 1 minus 10, we get 10 volts. So the VLK will be 10 volts. Yeah, just using the equations. As if you already notice, that's using the equations.